hotel, and you will see something similar here. So when customers had to pay this late checkout fee, then you see that their satisfaction significantly decreases, their trust in the hotel significantly decreases, loyalty significantly decreases. And that was quite an important finding for the hotel. But okay, let's do it step by step. So first of all, you see several packages here. We don't need any specific packages today for doing the regression, because we just do a simple linear regression or multiple regression. So you have tidyverse and Psych, just data which we use, packages we use for describing the data, having to load the data. ggplot2, I think you're familiar with that. Before we do the regression, we will have a quick look at some scatter plots, because I said it's important when you do regression, you make sure that you have a kind of a linear relationship. Otherwise, you might miss some important things in your data. So we use ggplot to do a scatter plot, simple scatter plot. And then we use the quantpsych package to calculate standardized regression coefficients. As I explained in the class, when you do a regression, you can have a look at unstandardized regression coefficients. So that's in the original measurement unit. But sometimes, in particular, when you have independent variables on different measurement units, it makes sense to look at the standardized coefficients, and quantpsych makes it very easy for us to calculate those standardized coefficients. Okay, let's have a look. So first, I load the data, the hotel data, and then we have a quick look. And you see the variables we're having in the data set. So we have an ID variable, gender and age from the customers, which we will ignore today. And then the penalty, that's the late checkout fee. So basically it was no means customer didn't have to pay penalty fee, and 1 means customers had to pay a late checkout fee. And then you see we have several relationship variables like trust, satisfaction, word of mouth, loyalty, and gratitude. You can have a look at some descriptives if you want to by using the summary and the describe function. I'll prefer the describe function. And you see here the mean values, mean age, for example, 40, and so on. But we will ignore that. First important step now, scatter plots. So in R, there are probably 50 ways of doing scatter plots. I'll show you 2 basic ones, and then we do it in ggplot. I would say ggplot is probably the most powerful one, and because you have different layers, you can add to every figure. You can easily make changes to your graphs. But there are easy ways to doing it. The first one is the plot function. Yeah, that's a very easy way. So what I did here is first step is I told R, okay, please take my data set and then only choose the columns 5 to 9. Why 5 to 9? Because those are my relationship variables. Yeah, you see column 1 is ID, 2 is gender, 3 age, 4 is penalty, and then 5, 6, 7, 8, 9 are the relationship quality variables. So I selected those, and then if you have a look at this data set, you see, okay, only the relationship variables. And then you just use the plot function on those variables, and you see R automatically gives you a scatter plot. Yeah. So that's a quite easy way of doing scatter plots. And you already see, yeah, it looks like that we have linear relationships, yeah, for most of our variables. So that's the
Sorry.
first. Yeah, please.
Could I possibly ask a question?
Yeah, please.
I don't know if anyone else has the same thing, but I think I've got the wrong data. I don't know if anyone else has got the one downloaded off Ellie. I've got different variables. It's like bundle, speed, aesthetics. I may have just downloaded the wrong thing, but I just wondered if anyone else had the same.
Maybe I could. Let me just have a quick look. Did you go to week 7?
I hope so.
Week 7, there should be a data set with the name hotel data. I put it, oh, I'm sorry, I put it under the whole cohort session.
I think bundle and speed is the data from the last week.
Yes, that's the one from last week. Last week we did conjoined. So maybe you used the data set from last week.
I'll try to download it again. Thank you.
Go to week 7 hotel data.
I downloaded it.
Okay, whole cohort session.
Don't worry, carry on. Thanks.
Is anybody else having the same problem?
Yeah, I have the same problem.
Really? Have a look. Man. Try the one in week 7, hotel data, because in my data it looks like it is the right one because it's exactly the one I just uploaded in R. No? Have a look again.
Sorry, it's taking its time. It's looking like it's going to work though.
Yeah, okay. It is week 7. Maybe you just choose the wrong one. It's in week 7.
Yeah, I'm not sure.
Whole cohort session content.
Yeah.
Okay. I can wait a second if you first want to upload your data.
I don't mind. Please carry on. I don't want to.
Okay.
Get you there.
Good. The second easy way of doing scatter plots is the pairs function. Yeah. So that's this one. And you see what you just do is you define your variables, similar to how you define it when you do a regression. Yeah. So there's tilde sign, then trust plus satisfaction plus word of mouth. You choose your data file, data df, and then you say, okay, oh, this is just a title. And if you run this, you would see you get a scatter plot again for the variables you selected. So those are easy ways of doing scatter plots. As mentioned before, the most powerful tool probably to do graphics is ggplot. And that's what we're doing now. Have just a quick look at some of the scatter plots. So first one is this one here. So in ggplot, you do a scatter plot by using the geom point function. Yeah. So what I did here, I do ggplot, selected the data set, and then I choose with the aesthetics function, I defined the 2 variables. Yeah. So the first one is, so I looked at trust and loyalty. So I want to look at a scatter plot between those 2 variables. So run that, and then you see we get an easy scatter plot. Yeah. So that's an easy one. And you see we don't see many data points. The reason is because they are overlapping at the moment. Yeah. You can avoid that by using the geom jitter function. Yeah. So you tell R, okay, put them a little bit next to each other, and then you see more what's going on in the data. That's what I did here in the next one. So I just added a next layer. So I did the same scatter plot between trust and loyalty, but adding this geom jitter function. And then you see it looks more as how it should look like with more data. Yeah. So that's the scatter plot we're having now. Yeah. And you see it is more or less, it looks like a linear relationship. We don't have, that's kind of interesting, we don't have many data points in the middle. Yeah. So about trust around 4 and loyalty around 4. So you see lots of customers either don't think the hotel is very trustworthy, or they think the hotel is very trustworthy. So more on the extreme ends, and not many in the middle, but it looks very like a linear relationship. And you can also ask R to put a line into the data set by using the method of least squares. So, and that's what I did in this last step. You see, again, it's the same scatter plot. I just added a line, yeah, based on the method of least square. Okay, that's it. So scatter plots, as I mentioned, it's just a first step to look at your data. It's very, always recommend to look at your data before you start doing more complicated analysis. It's always very good idea to visualize your data, look what's going on, and then start doing your analysis. Okay? Good. Any questions so far? I think you are familiar with ggplot. I'm sure you used it in other modules as well. Any questions so far?
Yes, can I ask, what is the jitter? Is that a variable for? I didn't follow, sorry.
Oh, the geom jitter.
Yeah.
So when this is the original data, this was the original scatter plot.
Yeah.
Let me see, where is it? Yeah, so geom jitter here, the second one here.
Mm-hmm.
So geom jitter avoids overlap of your data points. Yeah?
Yeah.
So very often those data points overlap, and when you use the geom jitter function, you avoid this overlap. That's it. Yeah. I'm not sure why I'm get an error message now here. Right, but that's all it is. Yeah. So you just avoid overlap between your variables. The data points, sorry.
Right. So what does this jitter do? So they just, if like data point overlap each other, they just separate it?
Yes, if the two data points are more or less exactly the same point, yeah?
Yeah.
Geom jitter puts them side by side, next to each other.
Ah, I see.
So that you can see more data points.
Right.
Yeah.
Okay, I got it. Thank you.
Okay. And then no more questions, sorry.
Hi, David.
Yeah.
Whether we need to consider the multicollinearity between some variables when we do the regression.
Collinearity.
The multicollinearity.
Yes. Yeah. I mean, yeah, that's more. I would say that's more an academic thing. Yeah. So multicollinearity basically means that you have high correlations between your independent variables. Yeah.
Yeah.
So, for example, it's quite very likely that you have high correlations between satisfaction, trust, and gratitude. Yeah. In particular, with satisfaction.
Yeah.
And you can test that. Yeah. I would say for practitioners, that's a very academic thing. Practitioners don't do that very often. Yeah. An academic would do that. But I also would say you get multicollinearity problems only when you have very, very high correlations. Yeah. So usually when it's above, I don't know, 0.7, 0.8 area, then you get multicollinearity problems. So it depends a little bit. Yes, when you write an academic article, you probably have to do it and test it. I would say in practice, it's not that relevant.
Okay.
Yeah.
Okay. Thank you very much.
Yeah. Okay. So here you see now satisfaction and loyalty. Yeah. So those are just scatter plots for all the relationships. Yeah. Word of mouth. Then you see here again scatter plot between satisfaction and word of mouth. Again, you see that's more or less a pretty good linear relationship between those variables. Next one, then we looked here at gratitude. Gratitude and word of mouth. Again, looks all right. Yeah. Okay, so this is just more a graphical exploration of the data, but that's not really an inferential regression analysis. Yeah. Any questions so far about the scatter plots?
I've got an error I've not seen before. It takes the first function, the sort of assigning the ggplot to SP2, but then if I try and display it, it says error in call graphics and then something about palettes being null. I don't know if you have heard of it.
Say it again.
I'll paste it in the chat maybe.
Yeah, post it.
Oh, is there a chat?
Yeah, there should be a chat. There's a chat, yeah. What's the difference of putting? Oh, no, that's the question. Okay. Invalid graphic state. No, I've not seen that before. Where you get it? Which line is it?
I get it lots of times. So 25, 31.
Okay, maybe
times when I try and call up the graph.
Yeah. Sometimes when you just copy code, there might be something. Yeah, it's always better to type it in by hand. Yeah.
Yeah.
Because sometimes when you copy it, you get there's something in Word or whatever in the PDF, and you copy it in into R, and then you get an error message.
It jumps around, doesn't it?
Yeah. Check again when you type it in. I know it's tricky doing it during the seminar because you don't have to try to follow and do it yourself. If you didn't get it again, drop me a message.
Yeah. Okay. Thank you.
Okay. Okay. The next step is actually pretty easy. So doing the next step, doing the regression, actually is pretty easy. It's just one formula you need in R to run the regression analysis. So in this step here, yeah, multiple regression analysis. So regression in R is just the LM function. So what I'm telling R is now, okay, loyalty is our dependent variable. So we want to look how those relationship quality variables, like trust, satisfaction, gratitude, affect our customers' loyalty. Yeah. So I'll say, okay, our loyalty is my dependent variable. And then you have trust, satisfaction, and gratitude as independent variables. That's all I do. And I used, obviously, my data set, DF, to run it. So then you ask for the summary of those results. And then you get this little table here. Yeah. So you also get a model fit, by the way. So usually, as I explained, when you do a regression analysis, you get two types of information. First is the model fit. So this is the R square here, yeah, and adjusted R square. And then the second information you get, and that's usually the more interesting one, is the coefficients. Yeah. So R square is just the amount of variance the independent variables explain in your dependent variable. And this is then the information for each specific independent variable and what kind of effect it has on your dependent variable. Okay, so based on what I explained on Monday, maybe do you have any idea what happens with trust in this case? Well, let's start with the first one. Well, what is the first thing you would look for when somebody asks you, okay, what is this variable important or not? What would you look for? What's the first thing you do?
You could look for the asterisks, which show significance.
Yes, exactly. You look at the significance value. That's the first step. And you see here, that's this last column, yeah? And then the asterisk is as well. And you see, okay, trust has a very significant, or has a, not very is wrong, has a significant effect on loyalty, yeah? So we know now that there is some kind of relationship between trust and loyalty. And then what's the second step?
I think is to see the coefficient of the trust, satisfaction, and gratitude.
Yes,
if
exactly.
If the correlation is positive, it means that there is the positive association with the loyalty and the trust, satisfaction, and the gratitude.
Yes, exactly. So the second step is then you look at the estimates. So that's your regression coefficient, yeah? The unstandardized regression coefficient. So in the original measurement units. So this was all measured on the Likert scale 1 to 7. So we look at trust. So we know it has a significant relationship, yeah, because we get 3 asterisks here. And then we see the coefficient is 0.19138. Yeah, so that's our coefficient. So, and it's, as we said, exactly, it's positive. Yeah, so we know there's a positive relationship between trust and loyalty. So we know if trust goes up, then loyalty goes up. Yeah? If trust goes down, loyalty goes down. Yeah? So that's what we know. And we also know how much loyalty changes when our trust changes, and customers' trust in our hotel changes. So we know if trust goes up by 1 unit on our 7-point Likert scale, so we measured it from 1 to 7, so let's assume the customer is on level 5, and it goes up by 1 to level 6. What happens with loyalty?
Increase by 0.19?
Yeah, it increases by 0.19. Yeah, exactly. Yeah. So if you go up by trust by 1, we know that our loyalty, our customers' loyalty goes up by 0.19138. Exactly. So that's it. Yeah. So we know trust has a significant effect on loyalty, and we know how it changes loyalty if we go up. What about satisfaction? Yeah, please. Sorry.
It's the same, but it's 0.58 now.
Yeah, exactly. It's same. It has a significant effect, positive effect, but it seems to have a stronger effect. Yeah. So the effect is 0.58. So if satisfaction goes up, the effect on loyalty actually is stronger. Yeah, because loyalty then goes up, increases by 0.58386, and so on. Now, again, finally, gratitude, also significant effect. Yeah, and again, so if gratitude increases, our loyalty increases by 0.22029. That's it. So as a manager, you now have all 3 relationship variables have a significant effect, but obviously we see here that satisfaction has the strongest effect. Yeah, so it's the most important one. It seems to be the most important one. So pretty easy, I would say, to do, and relatively easy to interpret at the end. Any questions about those regression coefficients so far? Okay. Then, as I mentioned, those estimates here, those are unstandardized coefficients. Yeah. And in some cases, it makes sense to look at standardized coefficients. Why? Because our independent variable might be in different measurement units. In this case, it's not a problem because trust, satisfaction, gratitude, they were all measured with the same scales. But it could be, for example, that you have a variable with a different measurement unit, yeah, in your regression function. And then it makes sense to standardize because then you can compare the effects of independent variables, and that's what we can do with this LM beta function. Yeah? That's from the from this quant-psych package, this one, and it's very easy. So you just use this little command here, lm.beta, and R automatically gives you the standardized regression coefficients. Yeah. So you see here, those are now the standardized regression coefficients. In this case, they are very, very similar to the unstandardized coefficients because they were on the same measurement units anyway. Yeah, so they look very similar. And those standardized coefficients are now just, they are always in standard deviations. Yeah, so it's the effect of the independent variable on the dependent variable, not in the original measurement unit, but in standard deviations. Yeah. So here, for example, the effect of trust, we see it's positive. Obviously, it's positive again. It's 0.1969192. So we know if we can increase our trust by 1 standard deviation, then loyalty increases by 0.1969192 standard deviations. That's it. The same for satisfaction. It's also in standard deviations now, and for gratitude as well. So that's something you can do when you see, okay, our variables are in different measurement units. I want to check, okay, how does it look like when the variables are all standardized? Yeah. And for example, one interesting thing here. So for example, based on those results, when you look at the unstandardized coefficients, you would, for example, assume that gratitude has a stronger effect, a slightly stronger effect than trust, but actually they are more or less the same. Yeah, when you look here, the standardized coefficients. Any questions about this interpretation? So the way you interpret the coefficient is the same. It's just that you're not looking at the effect in the original measurement unit. It's the effect in standard deviations. That's the only difference. Any questions about that?
So the results of the LM beta function seems like there is a little difference between the LM function, the regression coefficient. So which function we need to use? Yeah, it's
yes,
slightly different.
Yeah, they're slightly different. As I said, those are standardized. Yeah. So usually when you have variables like this, you would use the unstandardized coefficients. Yeah, because that's the original measurement unit, and it's quite straightforward to interpret. Yeah. So you know. Yeah. But let's assume you have a budget variable. Yeah. As independent variable, like advertisement budget. Yeah. Something like this. Yeah. Obviously, budget. You typically is in a different measurement unit. It's in pounds or euro or dollar or whatever. Yeah, and then it can be quite tricky to compare the effects of your independent variables because they are in different measurement units. Yeah, and then if you want to compare them, so if you want to say compare the effect of your independent variables, and you have independent variables with different measurement units, then you should look at the standardized coefficients. Okay.
Yeah, got it.
If you want to look at just at the effect, the individual effect of those variables on your dependent variable, then those estimates are fine. Yeah, the unstandardized. Yeah. When your independent variables are all in the same measurement units, like ours are in this case, that's fine. Just go with the unstandardized coefficients. It's just be aware that sometimes when you have independent variables with different measurement units, the unstandardized coefficients look different from your standardized coefficients. Yeah, yes. So you might think based on your unstandardized coefficient that one specific variable has the strongest effect, but actually when the variables are standardized, meaning in the same measurement units, then another variable might have the strongest effect. So this standardization is important, very important for variables with different measurement units. Okay.
Yeah.
Okay.
Yeah.
Okay. Good. So that's basically everything. So now we know. Okay, we have positive relationships, which is kind of was expected. Yeah. I mean, we know, or it's kind of obvious that trust, satisfaction, gratitude have a positive effect on relationship performance variables. You can also. I mean, we only looked at loyalty. Yeah. Obviously, we can also look at word of mouth as dependent variable. Yeah. So I just changed here in my regression function. I changed the dependent variable. It was loyalty. Now it's word of mouth. And then again, you get your coefficients. Yeah. And the interpretation is the same. Yeah. So quickly, which independent variable has the strongest effect on on word of mouth, on referral behavior, when you look at the regression coefficients.
Satisfaction.
Exactly. So satisfaction has the strongest effect. And can anybody say, how does the effect look like? So what happens if satisfaction increases by 1 unit? What happens with referral behavior? It's too easy. I think it goes up by 0.37669. Yeah. Second strongest effect seems to be trust. Again, positive effect on referral behavior. So if we can increase trust by 1 unit, referral behavior, word of mouth behavior goes up by 0.26839. Yeah. And then finally, we have gratitude, also a significant effect. Okay, so that's regression. So we know now, okay, our relationship variables have significant effect on both relationship performance variables, on both word of mouth and loyalty. Good. That's clear, I assume, yeah? How you interpret regression results?
Yeah.
Yeah, okay. So then, as I mentioned before, it was quite interesting to see for the hotel how those late checkout fees affect their relationship quality with their customers. And the first step, this is, I mean, it's quite similar to what we did when we discussed t-tests and ANOVAs. So we are basically looking at 2 groups. Yeah. So we are comparing customers who didn't have to pay this late checkout fee to customers who had to pay the late checkout fee. Yeah? And then to see, okay, is there a difference in terms of satisfaction, loyalty, trust, and so on? Yeah. So this first few lines of commands here is very similar, or basically exactly the same to what we did when we did an ANOVA. So I just first step was to look at the mean values. Yeah. So basically, I grouped the data set here. That's the first important line by penalty. So customers who paid the penalty, customers who didn't have to pay a penalty, and then I looked at some descriptives. Yeah, I looked at the number of customers who had in both groups. I looked at the mean value of loyalty in both groups, and also standard deviation. That's it. And then when we look at the results here, that should be look quite familiar to you. We see, so we have in this data set 138 customers who didn't have to pay a late checkout fee, and 139 customers who had to pay a late checkout fee. And you see what happens in terms of loyalty. When we look at the loyalty score, we see that customers who didn't pay or didn't have to pay this checkout fee had an average loyalty of 6.28. At the same time, customers who had to pay, loyalty only was 4.17. So there seems to be quite a difference between those 2 customer groups. But obviously, this is just descriptive. So far I didn't do any inferential statistics. So I didn't look whether this difference is significant, but it looks like a quite significant difference. Yeah. So 4.17 is quite a drop in loyalty. But we don't know it for sure. So the next step is then I did an ANOVA. As you know, you can also do a t-test in this case, because we are only comparing 2 groups. Yeah, we're only comparing customers with no penalty fees to customers who had to pay a penalty fee. So we could also do a t-test, but an ANOVA gives us the same results. So that's what I did here. Second step, so this command. So I just tested now for significance. Yeah, so I tested whether the difference between those 2 mean values is significant. So I used the AOB command, loyalty as dependent variable and penalty as independent variable. And then summary. And what you see here, you get very brief results. And the important thing what you get is this line here. Yeah, so that's the effect of penalties, those late checkout fees, on loyalty. Yeah, so this one line here. And you see, again, you look at the significance value first, and you see it's significant. Yeah. So based on this, we know that penalties have a significant effect on loyalty. Yeah. So that basically means that this drop in loyalty from 6.28 to 4.17 is significant. Yeah. So we know that customers who have to pay this fee are significantly less loyal than customers who didn't have to. Any questions about this, interpreting those statistics?
Maybe can you explain the code? Oh, like, I didn't get it.
Sorry, you're quite, I can't really hear you.
Can you explain the code from 73 lines to 78?
Can you make your, sorry, is it only me? You're not very loud.
Can you just repeat the code lines from 73 to 78?
73 to 78, yeah. Yes, so what I do here is, this one is, I say, okay, please, so those, I start with this one here, yeah? This percentage thing here, that's called a pipe function. That's a pipe. That's from tidyverse. It just means, and then do something else. So this means, take the data set df, and then group this data set by penalty. Yeah, so we know penalty are two customer groups, no penalty and penalty. So group by this penalty variable, and then that's again this pipe function, and then summarize. Yeah, so that's a summarize function, and then I tell R to do three summaries. First is count. Yeah, so this is this n command here, that please count the number of participants in the two penalty groups and save it in the count loyalty. Then the second summary is mean. So please calculate the mean loyalty for the two customer groups in no penalty versus penalty. This na.rm just equals true is just means please ignore all missing values. Yeah, so you know NAs in R are missing values. You could set this to false if you want to, and then R is not ignoring missing values. But I told R, please ignore missing values. And this command here is standard deviation. So I tell R, okay, and please also calculate the standard deviation for loyalty in the two groups and save it in sdloy. And again, missing values, please ignore it. And then, so that's this first command. And then I tell R, please give me the output, because I saved this all in mean loyalty.
Thank you.
Yeah? Okay. Any more questions about this output or this, how to do this? Or how to interpret the results?
No offense.
Okay, good. So obviously, so far I only looked at loyalty, yeah. But you can look at the other variables as well. I mean, this is, to be fair, it looks quite simple, but this was a quite significant result for the hotel, yeah. I mean, because when you think of those low checkout fees, which are very common in the hotel industry, but also in other industries, you have penalty fees as well for certain things. And it was quite significant for the hotel to realize the effect these fees have on the relationship variables or the relationship with the customers. I mean, these fees obviously there's a reason, yeah, and very often they mean short-term profit. But this study shows actually the long-term consequences these penalty fees can have, yeah, because if those penalties really, as this result shows, significantly reduce loyalty, that's a very detrimental effect for this hotel, or was a detrimental effect for the hotel. Yeah? So so it was, the analysis is quite easy, but the managers were quite surprised. It was a significant result for them. Okay, so this was loyalty, and then of of course, we can do and have a look at the other variables again. And then the second step was word of mouth. So this is exactly the same code like here. So I group by penalty, so looking at the two customer groups. And then I ask R to summarize, to give me some summary descriptive. So the number of customers again in the two groups, the mean value of word of mouth, and the standard deviation. Exactly to the same to the one I did previously. And then you get those descriptive results again, and you see the same pattern. Yeah. So you see customers who don't have to pay this penalty fee are more likely to recommend the hotel than customers who don't have to pay this penalty fee. So customers who don't pay the fee have an average of 5.84. Customers who have to pay the fee, only 3.90. So again, this is quite a significant drop, or seems like a significant drop, but obviously this is just descriptives. So I did the same. I run an ANOVA to look whether this is whether this is a significant effect. So I did the same as previously, just changing the dependent variable. So word of mouth is the dependent variable. The independent variable is penalty in this case. So I run this, and again, you get a brief ANOVA result. The important line is this penalty line, and you see, again, we get a significant effect. So we know now that those penalty fees significantly reduce customers' likelihood to recommend the hotel from 5.84 to only 3.9. And then, yeah, you can look at all the other variables and you will see all the same pattern. You will see that those penalty fees have a negative effect on all relationship quality and all relationship performance variables. So I did this here for Creditude. Again, drop from 5.63 in the no penalty group to only 3.67. Yeah. Again, checking for significance, and we see, yes, this is actually a significant difference. Yeah. So penalty fee significantly decrease Creditude, customers' Creditude. And then trust. Yeah, similar pattern. Trust significantly decreases from 6.44 to only 4.08. And here, the confirmation that this is a significant drop. And then finally, satisfaction. And we see the same. Obviously, satisfaction is negative affected as well. We see it drops significantly from, so here again, the significant value, and we see it drops significantly from 6.35 on average to only 4. So although those penalty fees are very common, they seem to have some negative long-term consequences on the relationship quality to your customers. Yeah? And to be honest, I was not surprised, so surprised by those results, because I had to pay penalty fees already in my life in hotels, and I was not very happy about it, not very satisfied. But this was a very important result for this hotel, to see how detrimental this effect can be. Questions, please. If anything difficult, anything you didn't understand.
Hi, David. I have a question.
Yeah, please.
Yeah, in order to explore which factor will influence the penalty, why we don't set the penalty as the dependent variable and set the other variable like the trust, the satisfaction, the gratuity as the independent variable, and then the regression.
So first of all, when we do the ANOVA, the penalty is the independent variable.
Yeah.
independent variable, and trust is the dependent, or the relationship variables are the dependent variables. So we look at the effect of the penalty fee on our relationship variable. So what was your question now?
The question is that why we don't set the penalty as the independent variable, and the dependent variable, and the set the loyalty, the trust, the satisfaction, and then the gratuity as the independent variable, and use this to apply into the regression.
So
I will put the code into the checkbox. Sorry.
Okay, let me see.
Yeah. Sorry, it seems like that I cannot put anything into the checkbox.
Okay. Okay, sorry, I'll try to explain it then. So just to get clear, so your question is your question why we use penalty as independent variable? Or is your question why didn't we use penalty in our regression function?
The question is that why we don't use the penalty as the regression independent variable.
Yes, we can. You could do that actually. Yeah. So, but that's a broader topic, to be honest. Yeah. So, so usually when you the analysis you use basically depends on the measurement the type of variables you have. Yeah. So usually you do a regression when you have continuous variables. Yeah. Like our relationship variables. If you have only continuous variables, you do a regression. Yeah. When you have an independent variable which is categorical, like groups, like in our case we have two groups of customers, then you tend to do t-test or ANOVAs. T-test and ANOVAs means your independent variable is categorical, your dependent variable is continuous. Yeah, so that's why I did it step by step. And you can, but actually you can use penalty. You can use categorical variables also in a regression analysis if they are dummy coded. So if they have only two categories. I think I explained that before. So you could actually, because regression is a quite powerful analysis. Yeah. So actually we could say here, for example, where's our regression function? In line 64, we could actually say, yes, okay, let's have penalty as variable in this function. Yeah, that's possible. And you get here, yeah, so if you run that, you get a result for penalty. Yeah, here.
Yeah. So so how we set the penalty as the dependent variable, and the trust, satisfaction, gratuity, and words of mouth as the independent variable in the regression model. So
no, if penalty would be your dependent variable,
that
doesn't make sense, because you would say you would use trust, satisfaction, and gratitude to predict whether customers have to pay a penalty fee or not.
Yeah.
But that's not the reason why customers have to pay a penalty fee. They have to pay the penalty fee because they check out too late. Yeah?
Oh yeah, it doesn't make sense.
It doesn't make sense to use it as dependent variable, because that's not what you want to predict. There's no reason to predict this, because we know why they have to pay the penalty fee. Yeah, they just slept too long or whatever. Yeah. Something else.
Got it.
Yeah. That's why we use this variable to look how it affects the relationship.
Yeah.
Okay.
Many sense. Yeah, got it.
Okay. More questions?
Hi, David. I have a question about the survey. How should we get the loyalty of the customer, or which question should be asked to get the loyalty?
There are lots of scales. So actually, there are lots of scales for all the variables. Yeah, there's a set of relationship quality variables which cover trust, satisfaction, gratitude, loyalty, word of mouth, and so on. I can have a look and show you one. They are pretty straightforward. So usually they are like, I'm very likely to come back to this hotel, and then customers from a scale to 1 to 7, how much they agree with this statement. Yeah. So 1 usually means I don't agree at all. 7 means I agree very much. Yeah. So usually, typically, those are 3 questions, 4 questions about loyalty, 3, 4 questions about satisfaction, and so on. If you want, I can show you or send you a few. Yeah. So those are the questions you use.
Okay, thank you.
Yeah. Actually, I think I showed you some in the session on Monday. I'm not sure if there was a loyalty scale as well. But if you're interested in this, I can send you some or show you some. Just drop me an email. But yeah, they're pretty standard questions. And as I mentioned before, you should not come up with your own questions, because your measurement needs to be reliable and valid. If you come up with your own questions, it's very likely that the measurement won't work. You probably won't realize it when you run your regression, but your results are faulty, and that's a problem. And so this measurement part is quite important. So you should use established measurements. As I said, I think in one of the classes, there are, for example, scale handbooks, like big books, and they're full of measurement scales for everything in business and management. Yeah, for every variable you can think of. Yeah, loyalty, that is for everything. Yeah, brand equity, brand performance, perception, whatever. Yeah. If you Google marketing scale handbook, you find those books, and they are full with scales, measurement scales.
Okay, thank you so much.
Hey, David, may I ask a question, please?
Yeah, please.
For example, are there examples when penalties are charged to customers, but the loyalty isn't affected with it by it? Because it seems like a logic thing to happen to if customers are charged with some penalties to have less loyalty.
So your question is whether those
whether if a penalty is charged to a customer, whether it indeed affects loyalty or not.
Yeah, I would say, I mean, in this case it did. Yeah, so we found those guests. I mean, it was, to be honest, it was a quite luxury hotel. Yeah, so when you pay lots of money for a luxury hotel, and then you check out a few minutes late and you have to pay a penalty fee, I would say that's quite frustrating. Yeah, I would say in many contexts we are used to it. Yeah, to pay that. So in a hotel, very often you know, okay, if I check out late, there might be consequences. I would say you find negative effects specifically when the penalty fee is kind of unexpected. Yeah, when you don't really aware of it, and then you really find significant effects. But still, we did a study 2 years ago with a mobile phone provider, and then we looked at what happens when you cancel the penalty fee. Yeah, so basically the customer expecting the fee. Yeah, like let's assume let's stay with the hotel. Let's assume you check out late, and then you come to you want to check out, and then the service employee says, yeah, I mean, oh, you're a few minutes late. Usually you have to pay £50 now, or half a day, whatever. But I cancel it for you today, yeah, because you are a special customer. The funny thing is, this little thing has a significant positive effect. Yeah, customers are so happy, delighted. Yeah, it increases loyalty. It increases word of mouth referral behavior. Yeah, on TripAdvisor, you see, oh, that was such a nice hotel, yeah, and so on. So with those easy things, you can create positive effects. Yeah.
Oh, okay.
Yeah.
Okay,
So,
thank you.
and then another thing, I mean, so this is those usually when you do studies with companies, those studies they look for pretty straightforward results. Yeah. So does this have an effect on this? Yeah. Obviously, we know the world is more complicated. Yeah. In lots of contexts, it depends. Yeah. It depends on customer characteristics. So who is the customer? Yeah. It depends on how the service employee reacts. It depends on the type of hotel, and so on and so on. When you do marketing research as an academic, we call this moderators. Yeah. So you can include all those things